Good morning. Yesterday we were discussing a few problems on a normal distribution. Today also we continue with the same kind of problems on normal distribution. Let's start. In an examination, 7% of the students score less than 35%. And 89% of the students score less than 60% marks. Find mean and standard deviation if the marks are normally distributed. It is given that P of 1.2263 is 0.39, P means 5. P of 1.2263, or I can read it as phi of 1.2263. Both the notations can be used here. P are phi of 1.2263. 1.22 is enough. 0.39 and phi of 1.47 is equal to 0.43. These are the given data. Find mean and standard deviation. That means mu and sigma are to be determined. Mu is to be determined, sigma is to be determined. And this particular problem is very important in examination point of view. This problem, very important problem. Let's mathematically write this first statement. In an examination, 7% of the students score less than 35%. Therefore, probability of students scoring less than 35% is 7%. 7% means 7% means per 100. 7 by 100, that is 0.07. Probability of a student scoring less than 35% is 0.07. Next, 89% of the students score less than 60%. 89% of the students score less than 60%. Probability of the students scoring less than 60% is 89%. 89% means 89 divided by 100, which can be written as 0.89. This is the first statement, which I have written mathematically. P where x less than 35 is 0.07 and P where x less than 60 is 0.89. And we know that standard normal variate Z is given by x minus mu divided by sigma. This is called a standard normal variate, SNV. If x is equal to 35, the corresponding Z will be 35 minus mu divided by sigma. Let it be Z1. If x is equal to 60, corresponding Z is denoted by Z2. X is equal to 60, therefore 60 minus mu divided by sigma. This corresponding Z is denoted by Z2. When x is equal to 35, Z is equal to Z1. When x is equal to 60, Z is equal to Z2. Therefore, writing this statement, P when x less than 35 is equal to 0.07 is same as writing the statement P when Z less than Z1 is equal to 0.07, because when x is equal to 35, Z is equal to Z1. Similarly, writing the statement P when x less than 60 is same as writing P when Z less than Z2, because when x is equal to 60, Z is equal to Z2. Therefore, that's what I have written here. P when Z less than Z1 is equal to 0.07 and P when Z less than Z2 is 0.89. This is Z1 and Z2. Z1 is 35 minus mu divided by sigma and Z2 is 60 minus mu divided by sigma. P when Z less than Z2. Let's mark that area where Z is less than Z1. Here Z is equal to 0. This is positive side of Z and this is negative side of Z. And this f of x always takes a bell-shaped curve like this. It is always symmetric about this straight line. And half of the area under curve will be here, and half of the area under the curve will be here. This is half. Z is less than Z1. Suppose this is Z is equal to Z1. Z is equal to Z1. This goes up to plus infinity and this goes up to minus infinity. This is half of the area. This is half of the area under the curve. Z less than Z1. This is Z1. Therefore, this is the area where Z is less than Z1. This is also the area where Z is less than Z1, right? This is Z1. Here Z is greater than Z1 and here Z is less than Z1. And how do you write this shaded area? This shaded area is 0.5, this area, right? 0.5. This area is 0.5 plus this area. This area is from Z is equal to 0 to Z1. That is denoted by P, where 0 less than or equal to Z less than or equal to Z1. Therefore, this is 0.5 plus P 0 less than or equal to Z1 less than or equal to 0 less than or equal to Z less than or equal to Z1 is phi of Z1. That's what I have written here. 0.5 plus phi of Z1 is equal to 0.07. 0.07. Therefore, phi of Z1 is equal to this is equal to 0.07 minus transform this 0.5 to RHS, you get minus 0.5. Therefore, this is equal to 0.07 minus 0.5 is a minus 0.43. Phi of Z1 is equal to minus 0.43. This is statement. Now, using the table, we can find the value of Z. You think like this: if the probability is equal to 0.43, then what will be the corresponding Z? It is specified in the problem, given in the problem. 0.43. See here, phi of 1.4753 is equal to 0.43. Phi of, this is the previous slide, phi of 1.4757 is equal to 0.47. Therefore, Z1 is equal to 1. What is happening here? Z1 is equal to 1.4757 along with this negative sign. Therefore, Z1 is equal to minus 1.4757. Similarly, P when Z less than Z2 is equal to 0.89. Z less than Z2. Same approach. Here Z is equal to 0 and this is the curve which takes bell-shaped curve. This is minus infinity and this is plus infinity. Z is equal to Z2 will be somewhere here. Suppose this is Z2 and required area is an area where Z is less than Z2. This is the area where Z is less than Z2. This is also the area where Z is less than Z2 and here Z is greater than Z2. It is not required. Only the shaded area is required. How do you write the shaded area? This is half of the area. Half of the area under the curve. 0.5 plus this shaded area. This shaded area is from Z is equal to 0 to Z is equal to Z2. You write it as P of 0 less than or equal to Z less than or equal to Z2. Therefore, 0.5 plus P where Z 0 is less than or equal to Z less than or equal to Z2 is denoted by phi of Z2. That's what I have written here. 0.5 plus phi of Z2 is equal to 0.89. Therefore, phi of Z2, this is not Z1, this is Z2. Phi of Z2 is equal to 0.89 minus 0.5, which is equal to 0.39. 0.39. Now search the table. 0.39. When probability is 0.39, corresponding Z is 1.2263. 1.2263. Z is equal to 1.2263. Now substitute these two results here. Z1, Z2. We have separate expressions for Z1 and Z2. Substitute. Z1. 35 minus mu divided by sigma. This expression. 35 minus mu divided by sigma is equal to Z1. And Z1 is minus 1.4757. Therefore, 35 minus mu is equal to minus 1.4757 into sigma. Therefore, mu minus 1.4757 sigma is equal to 35. Let this be equation number 1. Mu minus 1.4757 sigma is equal to 35. Let it be equation number 1. Similarly, by considering this expression, Z2 is equal to 60 minus mu divided by sigma is equal to Z2 is 1.2263. Therefore, 60 minus mu is equal to 1.2263 into sigma. Therefore, mu plus 1.2263 into sigma is equal to 60. Let this be equation number 2. Now just solve equation number 1 and equation number 2 to find the value of mu and sigma. I got it 48.65 and the 9.25. You just solve these two equations and verify whether these two are correct or not. You do that. I got mu is equal to 48.65 and sigma is equal to 9.25. You just solve these two simultaneous equations. So what is your answer?
Same, sir.
Same. Then it's correct. Is this clear?
Sir.
Okay. One more similar problem is there. This is also a question paper problem. It is a similar problem, but both are very, very important. In a normal distribution, 31% of the items are under 45 and 8% of the items are under 64. Find mean and standard deviation. This is a similar problem. Find mean and standard deviation. Let's write the first statement mathematically. In a normal distribution, 31% of the items are under 45. Right? Therefore, probability of an item under 45 is 31%. 31% means 31 divided by 100, which is equal to 0.31. Probability of any item to be under 45 is 31%. And the probability of any item to be under 64 is 8%. 8% means 8 divided by 100. That is 0.08. This is the first statement. P when x less than 45 is 31%. P when x greater than 64 is 0.08. And then I'm sure under 45 or s greater than Items are above 64 ಮಾಡ್ಕೊಂಡ್ಬಿಡಿ. I'm sorry. 8% of the items are above 64. So please change it. In a normal distribution, 31% of the items are under 45 and 8% of the items are above 64. Find mean and standard deviation. This is the problem. Now let's write first statement. In a normal distribution, 31% of the items are under 45. That is denoted by P, where X less than 45 is equal to 31%. 31 divided by 100. And 8% of the items are above 64. P when X greater than 64 is 8%. 8% means 80 divided by 100. Now standard normal variate Z is given by X minus mu divided by sigma. Z is equal to X minus mu divided by sigma. When X is equal to 45, corresponding Z will be 45 minus mu divided by sigma, and it is denoted by Z1. When X is equal to 64, Z will be 64 minus mu divided by sigma, and it is denoted by Z2. Z1 is equal to 45 minus mu divided by sigma, and Z2 is equal to 64 minus mu divided by sigma. Therefore, writing P when X less than 45 is equal to 0.31 is same as writing Z less than Z1 is equal to 0.31. This is because when X is equal to 45, Z is equal to Z1. Similarly, writing P when X greater than 64 is equal to 0.08 is same as writing P where Z greater than Z2 is equal to 0.8. This is because when X is equal to 64, corresponding Z is denoted by Z2. Therefore, Z greater than Z2 is equal to 0.08. The same two statements are carried here. P when Z less than Z1 is equal to 0.31. P when Z greater than Z2 is equal to 0.08. Let's mark this area. Z less than Z1. Less than Z1. Here Z is equal to 0, and this is Rf of X, which is symmetric about this. Z is equal to 0. This goes up to minus infinity, and here it is up to plus infinity. Here we have half of the area under the curve, and here half of the area under the curve. This is positive side of Z, and this is negative side of Z. Z less than Z1. Suppose this is Z is equal to Z1. Required area is Z less than Z1. Less than Z1. This is the area where Z is less than Z1. This shaded area. And this is the area where Z is greater than Z1, which is not required. The shaded area is required. This shaded area is, this part is half, 0.5, plus this part. This is from Z is equal to 0 to Z is equal to 1. Therefore, 0.5 plus P of 0 less than or equal to Z less than or equal to Z1. Therefore, this is 0.5 plus this is denoted by phi of Z1. That's what I have written here. 0.5 plus phi of Z1 is equal to 0.31. Therefore, phi of Z1 is equal to 0.31 minus 0.5, which is equal to minus 0.19. Minus 0.19. From the last statement of the problem, if probability is equal to 0.19, then corresponding Z will be 0.5. Therefore, Z1 is equal to 0.5 and it is negative. Therefore, minus 0.5. It is negative. We carry this negative sign here. Z1 is equal to minus 0.5. Now come to this statement. P where Z is greater than Z2. Z is greater than Z2. Let's mark this area where Z is greater than Z2. Suppose this is Z is equal to 2. And this is the curve. It goes up to minus infinity. Here Z is equal to 0 and here it is infinity. This will be half of the area under the curve. And this is half of the area under the curve. This is positive Z and this is negative Z. Z greater than Z2. Suppose this is Z2 then this will be the required area. This is the area where Z is greater than Z2. And this is the area where Z is less than Z2, and this is not required. How to write this? P when Z greater than Z2, this area. Let's consider area on the right hand side. It is half of the area under the curve. Therefore, 0.5. This entire area is 0.5. Required is the shaded area. Therefore, we have to eliminate this unshaded area. Unshaded area is from 0 to Z2. 0 less than or equal to Z, less than or equal to Z2. Therefore, this is 0.5 minus this is denoted by phi of Z2. That's what I have written here. 0.5 minus phi of Z2 is equal to 0.08. Therefore, phi of Z2 is equal to 0.5 minus 0.08, which is equal to 0.42. 0.42. When probability is equal to 0.42, corresponding Z is 1.4. It is given. Therefore, Z2 is equal to 1.4. Z2 is 1.4. Now substitute here this equation. Z1 is minus 0.5. Z1 is minus 0.5 is equal to 45 minus mu divided by sigma. Therefore, 45 minus mu is equal to minus 0.5 sigma. Minus 0.5 into sigma. Therefore, 45 is equal to mu minus 0.5 sigma. Let this be equation number 1. Now consider this expression. 64 minus mu divided by sigma is equal to Z2, and Z2 is 1.4. Therefore, 64 minus mu is equal to 1.4 sigma. Therefore, 64 is equal to mu plus 1.4 sigma. Let this be equation number 2. Just solve these two equations, simultaneous equations. Equation number 1 and equation number 2. Solve these two and let me know what is the value of mu and what is the value of sigma. I got it 50 and 10.
Yes, sir. 50 and 10.
50 and 10. These two problems are very, very important. You can expect one of these two problems in the examination, 100%. Next. The weekly wages of workers in a company are normally distributed with mean rupees 700 and the standard deviation rupees 50. This is the first statement. Using this statement, we can construct this standard normal variate. The weekly wages of workers in a company are normally distributed with mean rupees 700. That means mu is equal to 700 and sigma is equal to 50. And we know that Z is given by x minus mu divided by sigma. That is x minus mu is 700 divided by sigma is 50. This is what we call a standard normal variate. Z is equal to x minus 700 divided by 50. Find the probability that the weekly wage of a randomly chosen worker lies between 650 and 750. What is required? P where 650 less than x less than 750. This is to be determined. If x is equal to 650, what will be the corresponding value of Z? If x is equal to 650, Z will be 650 minus 700, that is minus 50 divided by 50 minus 1. If x is equal to 750, what is the corresponding value of Z? 750 minus 700 is 50. 50 by 50 is 1. Therefore, probability where 65 less than x less than 700 is same as probability where minus 1 less than z less than plus 1. Because when x is equal to 650, z is equal to minus 1. When x is equal to 700, z is equal to plus 1. Therefore, P when -1 less than Z less than +1 is equal to, now mark this area where Z takes values from -1 to +1. This is f of x. And this side, we have half of the area under the curve. This side, half of the area under the curve. This is positive side of Z and this is negative side of Z. -1 to +1. This is the point Z is equal to -1 and this is the point Z is equal to +1. The curve is symmetric about this straight line. Z is equal to 0. Now area required is between -1 and +1. This is the required area. This shaded area is the required area. Shaded area or colored area is the required area. Now split this interval -1 to +1 into two subintervals. First interval is from -1 to 0 and the second interval is from 0 to 1. Therefore, first interval is from -1 to 0, second interval is from 0 to 1. Right? This is equal to P. This is equal to P. Now reverse this inequality by multiplying by a negative sign. The inequality will be reversed. -1 less than Z less than 0 is same as 0 less than Z less than +1. 0 less than Z less than +1 and this probability as it is P 0 less than Z less than 1. This is equal to 2 times probability where Z lies between 0 and 1. They are same. P from 0 to 1 plus P from 0 to 1 is twice P from 0 to 1. Therefore, this is equal to 2 into P from 0 to 1 is denoted by phi of 1. Therefore, this is equal to 2 into phi of 1. The table value of phi of 1 is 0.3413. 0.3413. This is table value. This is obtained by using the table. 2 into 0.3413 is 0.6828. This is the probability of any worker having the wage between 650 and 750. Similarly, take up that second case. The chat is enabled now. You can mark your attendance. Second case, more than 750. More than 750. Z remains unchanged. Z is equal to x minus 700 divided by 50. More than 750 means P where x greater than 750 is to be determined. This is required. When x is equal to 750, what will be the corresponding value of Z? 750 minus 700 is 50. 50 by 50 is 1. Therefore, writing probability where x greater than 750 is same as probability where Z greater than 1. Z greater than 1. Mark that area where Z is greater than 1. This is our f of x. And this side we have half of the area under the curve. This side half of the area under the curve. And this goes up to minus infinity and this goes up to plus infinity. Z is equal to 1. It comes somewhere here. This is a positive quantity. Z is equal to 1. It comes somewhere here. This is the area where Z is greater than 1 and this is required. This is the area where Z is less than 1. How do you find this shaded area? This entire area on right side is 0.5. And from this area, if you eliminate this unshaded area, you get this shaded area. This unshaded area is from 0 to 1. 0 less than or equal to Z less than or equal to 1. Therefore, this is 0.5 minus phi of 1. 0.5 minus phi of 1 will be 0.1587. Phi of 1 is obtained by using table. Phi of 1 is 0.3413. Next, this one. Same kind of problem. The distribution of 500 workers in a factory is approximately normal with mean and standard deviation 75 and 15. Find the number of workers who receive wages more than rupees 90, less than 45. Similar problem. The distribution of wages of 500 workers in a factory is approximately normal with mean and standard deviation 75 and 15. Mu is equal to 75 and sigma is equal to 50. Therefore, standard normal variate Z is equal to x minus mu divided by sigma will be Z is equal to x minus mu is 75 divided by sigma is 50. That's what I have done here. X minus 75 divided by 15. First case. What is required in first case? Find the number of workers who receive wages, weekly wages, more than rupees 90. That means P where X is greater than 90 is required. P where X is greater than 90. What will be the value of Z when X is equal to 90? When X is equal to 90, 90 minus 75 is 15, 15 by 15 is 1. That means P where Z is greater than 1. Therefore, writing the statement P where X greater than 90 is same as writing the statement P where Z is greater than 1. Now mark this area where Z is greater than 1. This is same as previous case. Z is greater than 1. This is the area where Z is greater than 1. On this side, we have half of the area under the curve. This side, half of the area under the curve. How do you get this shaded area? You consider area on right hand side, that is half, and eliminate this unshaded area which is from Z is equal to 0 to 1. Therefore minus P where 0 less than or equal to Z less than or equal to 1. Therefore 0.5 minus this is denoted by phi of 1. Therefore 0.5 minus phi of 1, 0.3413. This is obtained by using the table. 0.5 minus 0.3413 is 0.1587. This is the probability of any worker whose wage is more than 90 rupees. How many such workers are there? 500 workers are there. Therefore, required is 500 into 0.1587, that is 79.35, approximately 79. If it is greater than 0.5 and more than 0.5, we can approximate it to 80, otherwise 75. 0.35 is less than 0.5, therefore approximately 79 workers. Next, you do second case. Less than 45. Phi of 2 is 0.4772. Using that, those who join now, mark your attendance first. Is this over, this problem? With this problem, we finished this module 3. So totally we finished 4 modules, 1 to 4, right? Tomorrow we can start 5th module. The answer bandidiya 11?
Yes, sir.
Okay. For tomorrow class, keep a calculator with you, without which we cannot solve problems. Keep a calculator and notepad with you. I'll continue tomorrow. Thank you.